In this final video for week 2 of Essential Python Scripting for GIS, focusing on Python Essentials, we're going to talk about data structures. Data structures are structures which hold data together. In other words, they're used to store a collection of related data. There are 4 built-in data structures within Python: lists, tuples, dictionaries, and sets. We'll see how each of these are used and how they will make life easier for us. A list is a data structure that holds an ordered collection of items. You can store a sequence of items in a list. This is easy to imagine if you can think of a shopping list, where you have a list of items to buy, except that you probably have each item on a separate line in your shopping list, whereas in Python you put commas in between them. The list of items should be enclosed in square brackets so that Python understands that you are specifying a list. Once you have created a list, you can add, remove, or search for items in the list. Since we can add and remove items, we say that a list is mutable data type, i.e. the data can be altered. In this example, the variable shop list is a shopping list for someone who's going to the grocery store. In the shop list, we only store strings of the names of the items to buy, but you can add any kind of object to a list, including numbers and even other lists. We've also used the for in loop to iterate through the items of the list. Notice the use of the end parameter in the call to print function to indicate that we want to end the output with a space instead of the usual line break. Next, we add an item to the list using the append method of the list object, as already discussed before. Then we check that the item has been added to the list by printing the contents of the list by simply passing the list to the print function, which prints it neatly. Then we sort the list by using the sort method of the list. It's important to understand that this method affects the list itself and does not return a modified list. This is different from the way strings work. This is what we mean by saying that lists are mutable and that strings are immutable. Next, we will finish buying an item in the market. We want to remove it from the list. We achieve this by using the delete statement. Here, we mention which item of the list we want to remove, and the delete statement removes it from the list for us. We specify that we want to remove the first item from the list, and hence we use the delete shop list with a 0. Remember that Python starts counting positions from 0. Tuples are used to hold together multiple objects. Think of them as similar to lists, but without the extensive functionality that the list class gives you. One major feature of tuples is that they are immutable like strings. You can't modify them. Tuples are defined by specifying items separated by commas within an optional pair of parentheses. Tuples are usually used in cases where a statement or user-defined function can safely assume that the collection of values will not change. The variable zoo refers to a tuple of items. We see that the length function can be used to get the length of the tuple. This also indicates that a tuple is a sequence as well. We're now shifting these animals to a new zoo since the old zoo is being closed. Therefore, the new zoo tuple contains some animals which are already there along with the animals brought over from the old zoo. Back to reality, note that a tuple within a tuple does not lose its identity. We can access the items in the tuple by specifying the item's position within a pair of square brackets, just like we did for lists. This is called the indexing operator. We access the third item in the new zoo by specifying new zoo brackets 2, and we access the third item within the third item in the new zoo tuple by specifying new zoo 2, 2. This is pretty simple once you understand the idioms. A dictionary is like an address book. where you can find the address or contact details of a person by knowing only his or her name. We associate keys or names with values or details. Note that the key must be unique, just like you cannot find out the correct information if you have two persons with the exact same name. You can also only use immutable objects like strings for the keys of a dictionary, but you can use either immutable or mutable objects for the values of the dictionary. This basically translates to say that you should only use objects for keys, or simple objects for keys. This basically translates to say that you should only use simple objects for keys. Pairs of keys and values are specified in a dictionary by using the notation D equals key 1 to value 1, comma, key 2 to value 2, and so on. Notice that the key value pairs are separated by a colon, and the pairs that are separated themselves by commas, and all this is enclosed in a pair of curly brackets. Remember that key value pairs in a dictionary are not ordered in any manner. If you want a particular order, then you will have to sort them yourself before using it. The dictionaries that you will be using are instances and objects of the dictionary class. Let's look at a dictionary in Python when. So here we've created a dictionary called AB using the notation already discussed. We then access key value pairs by specifying the key using the indexing operator as we discussed in the context of lists and tuples with a colon. Observe this simple syntax. We can delete value pairs by using the delete statement. We simply specify the dictionary and the indexing operator for the key to be removed and pass it to the delete statement. Here we're deleting the spammer from our dictionary. So next we're printing the length of the dictionary, how many items are in the dictionary. We can also print a tuple which lists the name and address of each item in the dictionary. And we can also add a key value pair. So we can also add a new key value pair by simply using the indexing operator to access a key and assign that value, as we've done for Guido here. We can also check if a key value pair exists with the in operator. So we're checking to see if Guido exists. So if our adding worked and we're printing a statement, Guido's address is, and listing his email address. So let's run this code and see what happens. All right, so here we go. We've printed Selena's email address. We've deleted the spammer and counted that there are 3 contacts in the address book. We have listed the 3 items in the address book. Then we've added a value pair for Guido, and then we're checking its presence in the dictionary with the if-in statement. Lists, tuples, and strings are examples of sequences. But what are sequences and what is so special about them? The major features are membership tests, i.e., whether they're in or not in expressions, and indexing operations, which allow us to fetch a particular item in the sequence directly. The 3 types of sequences mentioned here also have slicing operations, which allow us to retrieve a slice of the sequence, or just a part of it. First, we see how to use indexes to get individual items of a sequence. This is also referred to as the subscription operation. Whenever you specify a number to a sequence within square brackets, as shown here, Python will fetch you the item corresponding to that position in the sequence. Remember that Python starts counting numbers from 0. Hence, shoplist 0 fetches the first item, and shoplist 3 fetches the fourth item in the shoplist sequence. The index can also be a negative number, in which case the position is calculated from the end of the sequence. Therefore, shoplist -1 refers to the last item in the sequence, and shoplist -2 fetches the second to last item in the sequence. The slicing operation is used by specifying the name of the sequence followed by an operational pair of numbers separated by a colon within square brackets. Note that this is very similar to the indexing operation you have been using until now. Sets are unordered collections of simple objects. These are used when the existence of an object in the collection is more important than the order or how many times it occurs. Using sets, you can test for membership, whether it's a subset of another set, find the intersection between two sets, and so on. We've already discussed strings in detail earlier. What more can we know? Well, did you know that strings are also objects and have methods which do everything from checking part of a string to stripping spaces? The strings that you use in programs are all objects of the class str. So let's switch to Python Win to see some useful methods of this class. Here we see a lot of string methods in action. In this program, we've created a string object, name, and given it a value of Selena. We see the starts with method that is used to find out whether the string starts with a given string. The in operator is used to check if a given string is part of the string. The find method is used to locate the position of the given substring within the string. So find returns a -1 if it's unsuccessful in finding the substring. The string class also has a neat method to join the items of a sequence with the string acting as a delimiter between each item of the sequence. Here the delimiter is an underscore star underscore. We've created a list and then we're joining the delimiter to the list, which results in a list with underscore star underscore between each of the items. This is the last video in the Python Essentials series for week 2. Now that we have a lot of the basics of Python in place, next week we'll examine debugging your Python program.